past few weeks, there have been a lot of volatility in the market. Many financial institutes are interested in using machine learning analysis to make a big buck. In this research, we propose utilizing hierarchical learning methods to predict market trends. Hierarchical learning is a human-inspired method of approaching AI. It seeks to break large problems into a hierarchy of sub-problems, where each sub-problem is managed by a single AI module. The AI module for each sub-problem has a better grasp of the patterns within its jurisdiction. One way of forming a hierarchy is through temporal means. Given the price data of, let's say, a year, a hierarchy model may look at information pertaining to each day, followed by each month, then as an entirety of a year. Another way of forming a hierarchy is through conceptual means. This means breaking a large concept into a much smaller concept. In this research, we train two kinds of hierarchical models. One is a hierarchical natural language processing model, which utilizes news datasets, while the other is a hierarchical long short-term memory model, which utilizes price sequence dataset. The models are placed through supervised learning. The dataset were labeled bullish, stagnant, or bearish, according to their next day returns. Before pre-processing, we are working with a skewed volume of labels. We perform stratified sampling to achieve a balanced training dataset. For hierarchical NLP models, we are developing it using fast text. This is an architecture developed by Facebook AI Research that utilizes hierarchical learning to perform text classification. We designed our hierarchical fast text model to have only one hidden layer. The hierarchy is created using a hierarchical softmax function, which uses half-band encoding to build a hierarchy of classes. The hierarchical LSTM is designed and developed using Keras. It employs multiple hidden layers in its LSTM and is built upon an LSTM architecture. The hierarchy is achieved over temporal means, meaning that the model looks at the price sequence of different time periods, a day, over maybe 2 or 3 days, and over 5 days. To provide a benchmark, we'll be using the industrial standard model, ARIMA. ARIMA stands for Autoregressive Integrated Moving Averages. It is a mathematical model that has been widely utilized in the industry for many decades now. We placed the models through 5 independent tests. HLSTM had the best F1 score of 0.53, with HNLP coming in at a close second. In terms of performance by training time, HLSTM and ARIMA had acceptably low training time, while HNLP took slightly more than an hour. However, it should be noted that the training time for one epoch is roughly the same for both HNLP and HLSTM. The difference in training time arises because the HNLP model was placed through more epochs for training. To conclude, the research found that hierarchical models were far better than ARIMA model in terms of performance. In fact, the HLSTM was the best model among them all. This meant that more financial institutes should look towards hierarchical models for market trends prediction instead of continuing their reliance on ARIMA model.